Hi, Lori here to go over some of the questions that actually the 4 questions that we asked in our time value of money introduction video. So let's go ahead and start with the first one, which was, do you want $100 now or $110 in 2 years? Well, we know from the video that the answer is it depends. And what it depends on is the interest rate that we're going to use, or how much we could earn on that $100 if we put it in the bank for 2 years in a nice safe investment of some sort. So let's assume that we can put it in a nice safe investment, risk-free, at 9% interest. How would we figure out which one is better? Well, we'd begin with our formula in Excel, and we would put an equal sign. And because we're going to look at the present value, we want to know whether or not $100 now is worth more or less than $110 in 2 years. We're going to go ahead and look at the future value, and we put a parenthesis, and the rate is 0.09. The number of periods is 2. The payments is 0. We're just going to have one amount. We're going to put in our present value as a negative $100, and we're going to close our parenthesis because we don't care about our type. And we're going to find out that at 9%, if we took $100 now and put it in the bank, at 9%, it would be worth $118, which is more than $110. So we would want to take the $100 now and pop it in the bank. But what if interest rates were just 1%? Well, again, we're going to take our equal sign, and FV tells it we want to do a future value. The parenthesis brings up our options for our inputs, and we put down our rate is 0.01. Notice I'm putting it in as a decimal point. My number of periods is still 2. My payments, I'm just not making annual payments, just one present value up front. It's a negative $100, and these negative brackets tell you that you should put it in as a negative number, and then we'll just close it off with a parenthesis, and it will automatically assume the type. Ooh, $102. So wow, if we can only get 1% interest at the bank in a risk-free investment, then we should probably agree to take the $110 in 2 years, because at the end of 2 years, if we put the $100 we have now in a bank, it will only be worth $102. Let's see what happens when we do 3%. Equals FV, parenthesis, what's our rate? That'd be 0.03. Our number of periods is still 2. Our payment is still 0, and our present value is negative 100. Close our paren, hit the enter button. 106. Still probably better off taking the $110 in 2 years, because it's worth more than we could possibly earn in interest and principal on the $100 we put in the bank now. Let's try 5%. Again, we take equals FV, paren, our rate is 0.05, number of periods is 2, payment is still 0, present value is negative 100 still, hit return, $110.25. Woohoo! We're probably getting close to the break-even interest rate, where the present value of $100 is the same as waiting for the money and getting $110 in 2 years. In this case, because it's a little bit higher, we would want to take the $100 now and pop it in the bank. So let's go ahead and figure out what the rate would be that would make them exactly equal. And to do that, we hit equals rate, parenthesis, and it wants to know the number of periods. That's what NPER stands for. It wants to know the payment. We know that's 0. It wants to know the present value, which is 100. Here it wants us to put in the future value as a negative number. So I'm going to put it in as a negative 110. And we can do the rest, ignore the rest. And it says 0%. That doesn't look right. Let's try that again. Equals rate, number of periods 2, payment 0, present value 100, future value negative 110, close parenthesis. That looks better. 4.88%. And so if the interest rate is above 4.88, we want to take the money and pop it in the bank ourselves. So take the money now and pop it in the bank ourselves. If the interest rate is below 4.88%, then we want to wait and take the money in 2 years at $110. And if it's exactly equal to 4.88%, we don't care. So let's talk real quickly about what happens if we if interest rates go up. Well, we can see that if the interest rate goes up, our future value, that's what these numbers are, goes up. So if we go from 1% to 3%, our future value goes up. That's because our interest is compounding. And so not only are we getting interest on the principal, but we're also getting interest on the interest we already earned. And because the interest we already earned is bigger, we're going to have a larger number or a larger future value because the interest rate goes higher. Let's do another one. Our second question, do you want $1 million now or $100,000 a year for 12 years? I'm going to do this as a present value question. And because Excel is a little strange in present value, I always enter it as a negative PV because I like to see a positive number pop out. So I put equals negative PV parenthesis, and my rate is 0.09. Again, we're putting it in as a decimal point. Our number of periods is 12 years, so 12. Our payment is 0. We're just going to put, oh, no, our payment is $100,000. Do I have enough zeros? Nope. And our future value is 0, and we just close it off. And we find out that at 9% interest, we would probably want to take the $1 million now because the $100,000 per year for 12 years is only worth, in today's dollars, $716,000. Let's go ahead and take another look at another one. So what if our interest rate were just 1%? And that's more like today's environment. So let's take an equals negative. Don't forget that negative sign or you're going to get a red number. Well, here, I'll show you. PV, and our rate is 0.01. Our number of periods is 12. Our payment is 100,000. Enough zeros? Nope. And we can, our future value is 0. There. See how it came out as a negative number? I just think that looks confusing. So I always put a negative in front of my PV. There you go. So if our interest rate were only 1%, then we would want to take the $100,000 per year because it is worth $1,125,000. So the present value of $100,000 per year for 12 years, that's what this formula up here is asking, is $1,125,000 if the interest rate is 1%. Let's try 3%. So we're going to put equals negative PV per n, 1 per n, and our rate is going to be 0.03. Our number of periods is still 12. Our payment is 100,000. Our future value is 0. We're not getting anything extra at the end. Just close our parenthesis, and $995,000. So something interesting is going on here. Let's try 5%. And that will equal, let's see, I'm not sure I like that number. 0.0312. $100,000. That looks right. Okay. Let's try 5%. Equals negative PV. Rate is 0.05. Number of periods is 12. Our payment is 100,000. Our future value is 0. Close paren. That's coming out as a percentage. That'll happen to you sometimes if your spreadsheet's been used for something else before. So we just want to convert that over up here. We come up here to how we want our number formatted. We just put $, and it fixes it for us. We probably don't care about the cents, so we'll go over here and decrease our decimal points, and $886,000. But we'll take it back up so it looks like everything else. Beautiful. All right, so what if our interest rate were 12%? Let's take a look at that. So it's equal negative PV, and our rate is 0.12. Our number of periods is 12. Our payment is $100,000. Our future value is 0. Hit return, or hit close parenthesis and then return, and that is worth $619,000. So those payments, as you can see, as our interest rate goes up, our payments start to go down. I mean, the present value of the payments goes down because we can put the money in the bank, $1 million in the bank, and earn interest on it. So what rate would we need to get at the bank to make it exactly equals? Well, let's try equals rate, parenthesis, number of periods is 12, payment is $100,000. Oh, don't put commas in there. That always drives you crazy. Make sure I didn't do that up here. Let's see. Yep, no, I'm good. So equals rate, parenthesis, 12. Our payments are 100,000. Our present value is, we're going to put it in as a negative number, otherwise it won't work. And our future value is 0, and close parenthesis, and it tells us 3% is the interest rate. We can see a little bit more detail by going up here and increasing a number of decimal points. And so now we know that if the bank can pay us more than 2.922%, then we would rather take the $1 million now and invest it ourselves. But if the bank is only paying us less than 2.9%, then we would want to take the payments over time, which is $100,000 per year for 12 years. Let's go answer our third question. What is the future value of $10,000 after 19 years? Well, this is a future value question. Equals FV, parenthesis. Our rate is 0.09. Our number of periods is 19 years. Our payment is 0, because we're just putting in a lump sum of $10,000 in the very first year. Our present value goes in as a negative number, 10,000, and we can just close our parenthesis, and it will assume that we got paid at the end of the period, and that says it is worth $51,000. So if you put away $10,000 now and you wait 19 years and you're able to earn 9% interest, and you just let it sit in the bank or in the investment vehicle that you've chosen, it will be worth $51,000 after 19 years. What would happen if the interest rate were 12%? And the stock market has typically returned about 12%, so over the last 100 years. So this would be a good estimate for what you could earn on average over the long haul in the stock market. So let's try that again. Equals, we want an FV, future value. Our rate is 0.12. Our number of periods is 19. Our payment is 0, because we're just doing one lump sum. We're putting in $10,000 up front, and close paren. $86,000. Ooh, it's getting better. What if interest rates were only 3%? Well, let's try that. Equals FV. Our rate is 0.03. Number of periods is 19. Payment is payment is 0. So we're not doing anything annually, but we are putting in $10,000 to begin with. Close paren. $17,000. Ooh, not so good. That's why we want to find an investment vehicle that we're comfortable with, but that pays as high an interest rate as we can possibly earn. Let's try 5%. Now, you guys all know how to copy. We're going to go ahead and copy this formula. We'll paste it down here, and then we'll open it up, and we can just go in and right here change the interest rate from 0.03 to 0.05. Lickety split gives us a new number, $25,000. So what that tells us is that if interest rates were 5% and we put away $10,000 now, after 19 years, it would be worth $25,000, $269. All right, let's do our very last one, which is we're saving for college. Remember, we're putting away $1,000 a year for 18 years for our little pumpkin man in his diaper. And let's assume that we've got a 9% interest rate. Well, we want to know what it will be worth in the future. So that's an FV, a future value question. So equals FV, parenthesis, what's our rate? We're going to use 0.09%. Our number of periods is 18. Our payment is $1,000 per year. We're not putting anything in down as a down payment, no lump sum right now. So that's 0. That's our present value. Close our paren, and you've got a $41,000. Now remember, we need to maybe go in. I don't like it when it comes out as a negative, so I try to fix it. And the future value can be fixed by simply putting in your payment as a negative number, and that'll be $41,000. All right, let's try this again. What is our future value of a stream of payments at 12%, so 0.12. Number of periods is 18. Payment is negative $1,000, because that's how much we're spending each year. Our present value is 0. There we go, $55,000. If interest rates are only 3%, my guess is it's not going to look so good. So let's go ahead and do our copy and our paste. Save ourselves a little bit of typing. Go right in, and instead of 12%, we put in 0.03 for 3%. Hit return, $23,000. Gonna have trouble going to college on that. Okay, what if our interest rate were only 1%? Again, we can just paste our, whoops, we lost our formula there. Copy, paste. If you're not comfortable with copying and pasting, because you're not sure where you need to change your formula, don't do it. But for some of you that are feeling more comfortable with that, it is a little bit quicker to do. And let's just change our 0.03 to 0.01, and we'll see it's only worth $19,000. So let's talk about what happened to the future value of our stream of payments as interest rates went up. Well, from 1%, it was worth $19,000, and if you can get 9% on your money, you can more than double it to $41,000, and that's because the interest that you're getting every year on the amount that you've put away already is earning more interest, and that interest is at a higher rate, so it's compounding faster or at a better rate, and that is why you end up with a higher future value. If you have any questions with how to do this, try watching the video and then doing the example in your own Excel spreadsheet to see if you can get yourself to the same numbers, and that will tell you whether or not you're getting the concept. If you're having problems, go ahead and text Sean or Lori, and we'll set up a Skype session or something along those lines, FaceTime, so that we can make sure that you're doing this right in Excel. Thanks so much.